Okay, here we go. Gonna give this a try. Parallel circuits. We're gonna do a little video lesson here on parallel circuits. Hopefully help you with your homework assignments and your test scores, obviously, and most importantly, your overall understanding of electrical circuits. Okay, so first let's compare it to something that you've seen already, and that would be your ladder diagrams that you've used in the signal shop, or the res install shops, rather. Okay, we've had a couple rungs, we've had lights connected up in the different rungs and say controlled by a switch. All right, that is what we would call a parallel circuit, right? So these two branches here, those are in parallel with each other. Okay, and the characteristics of that, as you know, is the same voltage that we had for the supply was connected to each light bulb. All right, so when we turned it on and closed each of the switches, these lights lit up and basically to their full rated brightness because we applied the full voltage. Okay, so let's take that information and transfer it over to a type of diagram that we tend to use in our theory lessons, but essentially is the same thing. All right, so let me just kind of get rid of all this stuff here for now. And like I say, we'll transfer that information over to this diagram over here. All right, so our voltage applied would be here. We're using a DC power source. All right, so just a typical battery. So we will use that symbol to show that. We'll put a value to that a bit later. Okay, and we have a couple resistors we'll label R1 and R2. All right, and what we're going to add on to here is some labeling of what we call branches. Okay, so this, which we called rungs, say in a ladder diagram, in this type of diagram, we are going to call them branches because they branch off of the original circuit or the power supply. So if we had like an R3, right, over here, that would be branch number 3, but we're not going to do that right now. Okay, so let's get rid of that. Whoops, too far. Okay. All right, and that's just a reference for the parts of the circuit that we are talking about. Okay, so first thing I want to talk about is the voltage, right? Just as we had talked about in a ladder diagram, we had the voltage was the same across each branch, right? So that is the same in this. All right, so if we had E1 and E2, we'll put over there. Right, once we apply power to our voltage source over here, we get the same voltage across each of these branches, right? So from these points here, let me put that in a color that you guys can see. All right, we have the same voltage, right? So the first law of parallel circuit, or the rules, okay, is voltage is the same across all branches in a parallel circuit. Equal across all branches. Okay, so as a formula we can say ET equals E1 equals E2 equals E3, right, equals as many as we have. So if we could have 20 branches, they're all going to have the same voltage. If that's 120 volts for your supply, that's what we have across branch number 1 from these 2 points, and same as what we have across branch number 2. So we only have one resistor in each branch right now, so each resistor would get that full 120 volts. If that's a 9-volt battery for our power supply, then across R1 would be 9 volts and across R2 would be 9 volts, right? So rule number 1, as I said, voltage is the same across each branch. All right. Okay. So let's talk about the next thing. Let's take a look at current. Okay, zoom that in a little bit. All right, so we have, let's look at the current in each branch. Okay, so current flow, as we know, is going to be the result of a voltage across a resistance. Okay, so for each branch, for example, we would say for I1, this would be I1. This guy over here would be I2. Okay, so for both of them, it'd be the same, right? So your current, in this case, we're going to look at I1. We're going to use Ohm's law, so if we know the voltage, right, and we're going to put that across our resistance. All right, let me make that E look a little bit better. E1 over R1. Okay, maybe a smaller pen. Okay, so we can then determine what our I1 is. Okay, I2 would be the same thing. I2 would equal E2 divided by R2, right? And remember, right, our voltages are the same in this particular example. Okay, so that would be the same, and the current flow through each of the branch would totally be dependent on the amount of resistance in each of the branches, right? So if they're the same resistance, we would have the same current flow in each branch, but if they were different resistances, right, the currents would be different, right, based on the voltage applied divided by the resistance in each branch. Okay, so what we want to take a look at here now with the currents is our total current in this example, right? So we call that IT. Okay, so here, if you take a look at this junction right here, right, and that is called a node, right, or a junction. All right, and our ladder diagrams have referred to it as a connection dot, right? Right, and that's showing that there's a connection between the branches, right? So we have another path for current to flow, right? Because that's a parallel circuit, it has multiple paths for current to flow. Okay, so when we look at the current that is flowing into that node, all right, that is going to be the sum of the current flows in I1 and I2. Okay, so let's say, for example, let's just put some arbitrary numbers here. Let's say we determine that to be 10 amps, and this guy, let's say a little bit less, was 6 amps, right? This would be the sum of those two, right? And that would be 16 amps, right? So the law, Kirchhoff's law for current flow, states that the current flowing into a node has to equal the sum of the current flows exiting the node, right? So we had 10 amps and 6 amps in I2, right? Our I2 would have to be 16. So flowing into this node would have to equal the current flows leaving that node, and then back in here in this part of the circuit, right, it would also be the total, right? Returning that source would have to also be, we call that IT as well, right? Because it's this value here, it has to return into there to be the same, right? Has to equal the sum of the current flows in the two branches, right? Or any number of branches that we have, okay? So that next law is total current is the sum of all of the current flows in each of the branches. Okay, as a formula, IT equals I1 plus I2. If we had a third branch, we'd add that on. And as many branches that we had would equal IT. Okay, those are the first two laws of a parallel circuit that we're going to go over. Okay, simplest ones to understand. I'm going to stop it here on this part of the video. I'm going to do a second video, right, that is going to talk about resistance in video number 2. All right, so hopefully that kind of adds up a little bit of that. We'll talk about the resistance in another video, and then maybe a third video with a couple of examples.